what is gradient value? What is gradient? And what is gradient in a particular direction? Okay, so we'll see first what is a gradient, and then we'll first explain in the single variable. I would say a single vector, and then multivariate, multiple variable. So single variable, multiple variable. Multiple variable means two vectors. So when we do derivation, differentiation, so of a variable, so x is a variable, it varies, and suppose x something varies, x equal to x square means, I'm sorry, there is an independent variable called x, and there is a dependent variable called fx. So there is a function on x, and that is fx. So fx equal to x square. Now x is a independent variable, and there is a function on it, and it changes the square of the x. So if x is at any moment, if x is 2, then fx is 4. If x is 3, then fx is 9, because it is x square. Now how fx, x is an independent variable, but in calculus, if you go a little deep, everything is a vector. Means x is a vector. Vector means something which has a value and it has a direction. So in Euclidean space, suppose I say x is varying in direction of I. So there are three directions, I, j and k. So x is varying along the I. Means this is the kind of scenario. Now x is varying along the I-axis with a function x squared. So how much, if x varies 1 unit, then how much fx varies? Okay, so that is the question. So that is derivation, that is the gradient. So I can draw a graph of x and fx, and at any moment 1 unit of change in x, means along the I direction, if 1 unit of change is there, then how much is the change in fx? So fx, if I say, is y, so y equal to x square. But since it is x is independent on fx, x is not dependent upon fx, so x is not dependent upon y. It is only possible if y is orthogonal to x. So I'll take y-axis, that is 90 degree to x. Now y equal to x square. So how much? So this is y-axis, this is x-axis. Okay. So along y-axis, how much y-axis changes if there is change in x-axis? So that is derivation. So derivation is always a vector. It cannot be scalar. So if I say y equal to, or fx is equal to x square, then dy by dx means change along the y direction, because there is a change along x direction. So if along the x direction, if 1 unit changes, then how much it changes along the y direction, that is 2x. So if x is 10, then at that moment y is changing 20. So if x is 10 and I take any unit of length, 0.5, 0.25, 1, whatever, but 1 would be very big, 0.5, 0.25, then if it is 0.25 change at 10 location in the x, in direction of x, then along the y, 0.25 into 2 means 0.5, double it will change. So in x direction, if it change 1 unit, in y direction it would change 2 units. So that is differentiation, gradient. So if we draw the graph, so x square means it will be like a parabolic graph, and then at that moment we draw a slope. So that is differentiation. So that slope talks about the change in x-axis along the change in y-axis. What angle we get, so tan theta would be the change in the y and change by change in the x. Means if that is the slope, then perpendicular by base, so that would be the tan theta. Means that is that is the kind of uh, uh, in not in the degree, in the other mean radian. So in radian we will get how much is the kind of slope. So gradient is differentiation in the sense how much things vary in y direction, if how much unit, if there is variation in 1 unit variation in x direction. So this is gradient. Now this is single variable. I mean single variable. Suppose I have a plane and plane 1 is x and 1 is y. 1 is x and 1 is y. Now on the plane I have kind of one sphere is kept. Okay. So if I say that what is the formula of a sphere, so that is x square plus y square plus z square equal to 1. So if I consider z as fxy, then it would be 1 minus x square minus y square. Okay. Suppose that is the z square. Now I won't go into that much detail. Probably in next session we'll try to cover the sphere. Now the idea is what is a gradient direction along an axis. That is the question. So we have, if I calculated the gradient dy by dx, then gradient direction is along y-axis. But I would say gradient, how much gradient we are getting when a vector is changing along y-axis, that is fx equal to x square. If fx equal to x square plus y square, then how much it would gradient would change if things changes. Means now there are two independent variables, x square, x and y. If I say both are independent to each other, means they are orthogonal to each other. So x is in I direction, then y is in j direction. Now I have a fxy multivariate x square plus y square. So at any moment, if I want the variation of the fxy when there is a variation in I direction, what is the variation in fxy if there is a variation in j direction, y direction? So this is multivariate gradient. We calculated nicely the gradient for the single vector. Now gradient for the multivariate vector means two vectors, x and y, and both are independent of each other, in a sense they are orthogonal. Now x square plus y, if we want to calculate the gradient, then first we will calculate the partial gradient with x and partial gradient with y. So if I calculate partial gradient with the x, so that I know the variation, if there is variation along the I-axis, then how much fxy would change? Then it would come as 2x square. Okay, so it is dx square plus y square by dx. So 2x plus y 2y square by dx. So y is not changing along x-axis because they are orthogonal. So that is 0. So gradient of fxy along I direction, with change along I direction, is 2x. Similarly, gradient of fxy when there is change along y-axis is 2y. So I would say that gradient of fxy, function fxy, is 2x along y-axis, means if variation is along y-axis, if variation is along y-axis, and not plus, and 2y if variation is along j-axis. So 2x if variation is along I-axis, 2x if variation is along j-axis. So that is gradient, multivariate gradient. So multivariate gradient is in common, it's not plus. So if x square plus y square is a function, multivariate function, fxy, f braces x comma y brace end equal to x square plus y square, then gradient of fxy is 2x variation in I direction, comma 2y variation in j direction. Okay. Now I know that gradient variation in fxy if there is variation in I direction and variation in z direction. So that is calculated. Now someone can make a silly question. What would be the gradient if there is variation along I direction? So I is a unit vector. If that is the case, then we have to do directional gradient. So this is called directional gradient. Now gradient, I know the gradient of fxy along the I-axis. Then that is denoted as gradient, whatever the sign is, I believe it is inverted delta, and gradient d or simple capital D, and then in the I direction. So if I say that would become dot product. So whatever gradient we had 2xi plus 2yj dot I. So if that is the case, then it is 2x. So the gradient's variation, because it varies, if it varies only in x direction, I direction is 2x. How much is the gradient variation if the change is along only j direction? Then 2xi plus 2yj dot product j, that is 2y. What is the variation? What is the variation of fxy when along the vector direction k? Then 2xi plus 2yj dot product to k means 0. The cos 90 is 0. So along j, if something varies, then gradient doesn't vary. What is the gradient variation along any vector u? So whatever gradient we calculated dot u. If there is variation along any vector u, then how much that variation is, it affects the gradient. If there is any variation along I, then it is 2x. If there is any variation along j, then it is 2y. If there is any variation along k, then it is 0. If there is any variation along a vector u, that is directional gradient. This is directional gradient's variation along any vector u. So whatever we calculated 2xi plus 2xi comma 2yj dot product of u. Now u has component in I and j. If that is the case, then suppose that is ui and uj, then it will become 2x ui comma 2y uj. If u does not have component in I and j, that is k, then complete 0. If it has component only in I, then y factor gone. If it has component only in j, the next component gone. If it has component in both directions, then directional kind of gradient along y direction variation along u direction is possible. U must be unit vector because we are concerned about the direction one. So this is directional. This is a directional gradient. Means how gradient varies when there is a direction. Okay. So we'll see slowly more towards it.